So good afternoon, Geospatial community. Welcome to CGA's first ever virtual forum in our unusual times. It's so wonderful though you could be here. I'm Ross Mintermeyer, director of the center, and I'm delighted to have Dr. Bill Rand with us today. Also delighted to welcome about a dozen incoming PhD students to our Geospatial Analytics PhD program. They're here as part of a virtual visitation day. So it's wonderful to have you all here and a part of our forum today. Back to Bill. He's one of our newest faculty fellows to join CGA, and I think he makes a really unique contribution to our growing group. He received his PhD in computer science from the University of Michigan, and he's now an associate professor in the Poole College of Management, where he applies geospatial analytics to understand complex systems broadly, but more specifically things that going on in our economic markets, organizational learning, and the diffusion of information. And today he's going to use some examples from natural disasters to talk about how location affects social media. So really looking forward to your presentation, Bill, and wonderful to have you join us today. Take it over.
Cool. Awesome. Thank you, everybody. Thanks for having me. And before I pull up the presentation, I just want to say, I've been very interested in geospatial and spatial analytics in general since at least my grad school days, if not before. I actually worked with some people at the School of Natural Resources and the Environment at the University of Michigan, specifically a guy named Dan Brown while I was there. Did a lot of modeling of suburban sprawl. And so this kind of, in some ways I'm very happy to be back involved with an organization that kind of does a lot of work in this space. Since then, my path has kind of meandered back and forth all over, but I've always kept one eye on on spatial problems, right? And for a while there, I was doing a bunch of work on, and still do a bunch of work on social media. I would say the vast majority of my research right now reflects some sort of understanding of how social media influences our daily lives, right? I've done some work in the past on how that both affected hurricanes and was affected by hurricanes, right? In some respects, I shouldn't say affected the hurricanes, affected responses to hurricanes is a better way to put it. And I'm going to highlight some of that work today. Some of this is a little bit older work, but recently I've started to get more interested again in some work that has to do with how social media can be used by managers to kind of make spatial decisions. And I'll end the talk today with some of that. That part doesn't involve as many hurricanes, but it's still kind of interesting work about spatial analytics and social media. So I thought it might be interesting to talk a little bit about it. So I'll dive right into the presentation. And if you have a clarification question, I've been teaching on Zoom for a while now, so I'm pretty familiar with it. So if you have a question or something you want to ask, feel free to use the little raise hand icon, and I'll try and pay attention to that as I'm going along. You can always also pop a question into the chat if it's something that you don't think is, you don't want to interrupt the flow of the conversation, but rather just we're curious about it. So let me go in and add the share screen, and we should be good to go. Okay. Okay, so as I mentioned briefly, I've become very intrigued by the question of social media, and I feel like specifically, I as a social scientist now, having made the transition from computer science, I'm really interested in understanding what social media and what all the big data sources that we have out there about individual behavior can tell us about human behavior and help us better understand the social aspects of society, right? I really do think it's possible to use these kind of traces of behavior, right? They're not really the exact actions people take necessarily, but the traces of those actions to help better understand society as a whole. And with that, I'm going to tell you I phrased it as two stories and an anecdote today, right? And the first story, I'm going to talk a little bit about how does information move about during disasters? How do people find out things about disasters and about events that are unfolding quickly? And then the second story, I'm going to talk a little bit about how does that actually relate to actions that people might take during those disasters, right? And then finally, as I mentioned briefly, I'm going to at least mention at the end, I may not get a chance to go into much detail about other aspects where we might use this information to make long-term planning and spatial decisions, right? So the first story I call urgent diffusion. And this is the topic I was writing about for a while, and I'm still very interested in it. But my interests have been sidetracked by other things along the way at times. But urgent diffusion is this idea that in many contexts, time plays a critical role in information diffusion, right? You can, man-made crises such as biological attacks, natural crises such as hurricanes or pandemics, right, is an area where that's definitely the case. Critical news events such as election results or global political events, and brand crises for, you want to talk specifically from a marketing or business perspective, such as brand reputation issues. Time is going to play a critical role in the information diffusion. It's going to affect how you respond to people, how you might decide to play things out, right? And so one question you might ask is, well, there's a lot of measures, models of how information diffuses out there already, right? Why would it be important to model these differently in the urgent cases, right? And I would argue that if we want to construct optimal policy responses to the crisis, then we need to understand how that information diffuses. And so, for instance, for the CDC, it's important to get the word out quickly and to the right people to make sure that we're social distancing in the right way, that we're taking the right actions, and I think that the spatial aspect of that has become really clear recently, right? It may very well be the case that social distancing needs to be more strictly enforced in hot states like New York and Michigan, right, over places like Wyoming where there aren't as many cases and many issues. So how do you correlate all those kinds of aspects together? For news agencies, you need to understand what the pieces of information are that are grabbing attention and who's really distributing them. And for brand managers, right, you want to identify how quickly information will spread. I always put down the little Dilbert icon here, and Dilbert cartoon. And, this talks a little bit about how marketing is basically just guessing. And that's often kind of a trope in my field right now, right, in my academic field, that we really don't know that much about what marketing does. There's a famous John Wanamaker quote that, half the money I spent on marketing is wasted. I just don't know which half, right? And really what a lot of me and my kind of colleagues in the business world are trying to do is trying to figure out better how to understand the role of advertising and marketing and information diffusion, how those roles affect consumer decisions, right? And I think that has a lot to say, a lot of effects on society as well as on plain old companies trying to sell products, right? I lost the control. There you go. So as I mentioned briefly, there have been a lot of approaches in the past to diffusion. There have been some what I call non-urgent models of diffusion, such as the BAS model, which was a model developed for like the distribution of, or the adoption, I should say, of things like refrigerators and air conditioners and kind of household appliances. And it talked a lot about information as well, because the way you decide to adopt a refrigerator is because your friends have refrigerators, right? And then there's also things like the Cascade model, which was this model that came out around the turn of this last century in 2001, right? Where Goldenberg and others were looking at how news about a company spreads, right? And there are a couple others that I don't list here. There's things like a threshold model, right, which is the Granovetter model of information diffusion. And there's something called complex contagion models, right, that are out there as well. And so one question happened that we just, in the first paper we wrote on this topic, one question we just had was, could we just reuse these other models to understand how information diffuses? And so, I'll spend a little bit on details, but I won't go into too much of this. So there's an equation-based version of the BAS model, which simply says that the fraction of adopters at any time point is equal to the probability of adopting due to innovation, right, plus the probability of adopting due to imitation times the cumulative fraction of adopters in the past, right? This is essentially a hazard rate model that just models. And you know, small note, there's no space in this, right? There's no kind of notion of any heterogeneity, right? But this was the model that dates back to the late 1960s and seemed to do pretty well for forecasting adoption rates of a lot of large products out there, right? So, you know, Roland Rust, who's at University of Maryland, and I, we decided we'd build an agent-based version of this, right? And the agent-based version, each individual in the model has a probability P of becoming aware independent of the social circumstances, and then they have some probability Q times F of T of becoming aware, where F is the fraction of the neighbors who had become aware in the previous time steps, right? And then you just repeat that until everyone's adopted. Now, you know, the nice thing about the agent-based model is it also has these aspects where you can add in a spatial notion to it, right? You can add in a social network, right? You can add a lot of aspects that would be hard to incorporate in the equation-based model. Okay. So, and somehow, we looked at two different types of data when we looked at this, right? We looked at 15,000 users who we tracked everything they said on a topic, and we knew their following networks. So we knew this network of users very well. We knew exactly who was following whom and what all the tweets that they possibly sent out on a particular topic, right? We then also did what we called a keyword-based collection of users, where we basically chose a couple of keywords. In this case, there were things like Hurricane Irene and Irene, and we collected all the tweets on those topics. And we used the tool that we developed in my old lab called Tweeter, with Twitter Eater, in order to collect all this. Nowadays, I would probably use something like Crimson Hexagon, which is kind of a nice tool to almost get a lot of this data for you regardless, right? And we looked at 4 different urgent diffusion events. We looked at the capture and death of Osama bin Laden. We looked at Hurricane Irene. We looked at Hurricane Sandy. And we looked at election night of 2012, so about 8 years ago. That's kind of gives us a bunch of data to work with. Oh, this slide's out of place. This should be flipped up. Sorry about that. But I'll mention this real quick. So another model that was in this space was the independent cascade model that we looked at. In this model, each individual has a probability P of becoming aware independent of social effects, and some probability Q of becoming aware when any of their neighbor affects. So it's a little bit different than the BAS model. In the BAS model, you constantly have this probability of becoming aware at any time step due to the fraction of your neighbors who have adopted. In the independent cascade model, every time one of your neighbors adopts, you have a one-shot probability of adopting because of Q, right? So it's a little bit different. There's some arguments to be made that the independent cascade model might better capture some of the actual mechanisms of things like Twitter and stuff like that. So, obviously, since this is a spatial area, I wanted to present some of the spatial analysis that we did as well, besides the pure modeling analysis. And I'll get into that in even more detail when I switch to talking about the donation aspects, right? But in this context, right, what we did was we just kind of took, for all those tweets that we had on the hurricanes, this is Hurricane Irene, we took all the tweets we had on that topic and we plotted where those tweets actually were, right? And you'll notice these blue dots heading up these coasts. That's actually the actual hurricane itself. And this is another hurricane over here that came in just after Hurricane Irene, right, in 2011. And this is a screenshot at one particular time of the tweets going on about the topic. But we can, of course, look at the dynamics of these tweets. So this is a view of all the tweets about Hurricane Irene in the world at the time. And you can see the hurricane pulsing up the East Coast, getting closer and closer. And at one point along the way, you'll see, kind of some more tweets. There we go. So as the hurricane hits New York, you see a lot more tweets happening around that particular topic, right? these, and so someone in the chat actually asked, is this the location of the tweet determined by where the person says they are, as in their profile? No. So for these particular tweets, I am limiting our data collection to only the tweets that are geotagged. So these are tweets where the user has turned on location on either their laptop or on their phone, and they actually tagged that tweet specifically with the location, right? And I'll go on. This is Hurricane Sandy, so you can see a slightly different graph. And so as a result of that, right, we're getting to the accuracy of the device, and assuming, and I'll make one small caveat, assuming they're not spoofing the geo coordinates, which rarely happens, but it does happen. These are exactly where the person is tweeting from at the time that they sent that tweet, right? And here's the Hurricane Sandy tweets. And one of the things I'll mention is that it turns out, we plotted where the hurricane was at the time, but it turns out that we didn't actually need to do that. It turns out in our data, there is a tweet that occurs once every so often that appears that where someone spoofed the geo coordinates of the hurricane themselves. Now, it turns out it's a bot that's essentially providing details about hurricanes that are coming in. So this bot is providing the barometric pressure, the wind speed, and all that as measured by NOAA of the hurricane, right? But for some reason, whoever did this in the bot went in and tweaked the geo coordinates of the tweet so it looks as if the tweet is coming from the center of the hurricane, which I'm not sure why they did that. We were a little confused by this when we first saw it. We're like, why are there tweets in the middle of the Atlantic, right where the hurricane is, right? It's kind of funny to me because no one sees this data, right, unless you're actually looking actively at it. So I'm not sure why they did that, but that's an example of how you could potentially hack this data or misconstrue this data, right? Now, that being said, one other caveat I should mention about these tweets is we only have the exact location for about 1% to 3% of the tweets, right? That's about what we see on average for all Twitter collections, right? As to how many actually are geotagged, right? Now, during times of natural disasters, this number tends to go up a little bit, right? But in general, we never see much more than about 5% of the tweets actually featuring a geotag. Right? So these are interesting patterns. You can kind of look at them, try and understand what's going on and how the diffusions happen. But to get back to the original question we had was, could we actually map these models of non-urgent diffusion to the temporal data of looking at models of the data spread, right? And so what we did was we did a simple old calibration exercise where we just scanned all the potential parameters that would fit these models using the agent-based approach. And then we looked at the results to identify areas of the space that seemed to be the most well fit, right? And then we recreated simulations over time of the best fitting parameters for those particular events. And what's interesting is that you can see that there's some deviations between the different types of events and the different spaces, different results we saw. So for instance, the Bin Laden event, we were never able to really capture. It's just that the actual underlying real, so the blue lines here are the real data and the red lines are our models, right, as best fit. And we always seem to miss this big gap in here, right? Election data also seemed to have some weird hiccups, but in general, we were able to fit the data a lot better over time, right? Then, with regards to Irene and Sandy, we actually able to get pretty good fits over time. And we have some thoughts as to why that is. So this is kind of the end of like the first story to some extent. Basically what we found was the models fit the hurricanes better. And we think that partially that's because they extend over a long period of time, right? So as a result, we're kind of averaging over a lot of the small changes, small spikes that might happen. The models also seem robust to small changes in the parameters, right? Which I didn't show here, but is in the paper. But there was no clear best model. And in future work, we hope to incorporate seasonal effects, spatial effects, right? News shocks, developing a taxonomy, and examine sub-events within the greater events. One small note I'll mention, right, is that it turned out that Osama is specifically, that one was interesting. Let's see if I can go back to it. This beginning of that particular event, it feels like it didn't really have much of it. So a lot of these models rely upon the fact that social spread is greater than independent awareness. In other words, you're much more likely to find out about things from your friends or on social media than you are from just randomly turning on the TV and watching it, right? But in bin Laden case in particular, it seemed like it happened much quicker from the than we would expect from social spread. So we think that this was driven essentially by a huge mainstream media involvement right off the bat. And that it's almost like everyone overnight woke up and realized that Osama bin Laden had been captured, right? And so there wasn't as much of this kind of social spread as you see in the other cases. Okay, I'm going to switch topics, but before I do, there was another question that popped up. So is there demographic info on which users enable geotagging in their tweets? How representative are they of all users? So, that's a great question. I actually haven't explored it too much myself. There's very little demographic info available publicly on the users explicitly from the tweets. What you could get from them, and so if you want to carry this out as a study, which I think would be interesting, what you could get is you can get things like a self-described profile, a self-described location, and the devices that they're actually using. So if you wanted to look at demographic, and you can also get their supposed profile pictures and their names. So you could use that potentially to try and back out demographic information. I could say in general, right? I should say in general, what we found on social media, especially on Twitter, is that Twitter actually seems to overrepresent minorities in the population compared to the real population. For whatever reason, it seems like a lot of, and I'll put a caveat on this, but a lot of people who are less wealthy and who are not necessarily, or from an underrepresented minority group such as Black or Latinx are more likely to be active on Twitter than the normal representation in public, right? So there, in general, Twitter seems to be very useful from the perspective of getting access to underrepresented minorities. Now, I should say that comes with a caveat, which is that another way to think of minority would be to think of urban populations versus rural populations, and Twitter overrepresents by orders of magnitude urban populations versus rurals, right? So in that sense of underrepresentation, it's exacerbated by Twitter. But I don't know what the relationship is between that and geolocation being turned on. That'd be a great question to investigate. So let's talk a little bit about how this kind of activity motivates donations. And in this particular context, so the first work we published, this paper is interesting. In this paper in particular is not yet published. It's actually one of those papers where I feel like it's my favorite paper that I never published. And at this point, the data might be getting too old. You'd almost have to redo it, right? What we looked at was the relationship between people's attention on the hurricane, donations, and tweets, right? And our thought was that we could use Twitter as a way to measure when different parts of the country are interested in the hurricane or in a natural disaster. And then we could work with the American Red Cross to kind of time messaging to those parts of the country to encourage additional donations, right? And that's the basic idea. So we're using Twitter as kind of a measurement of interest, with the idea that that measurement of interest is also a measurement of whether or not someone's likely to donate, right? We focus for this particular context on Hurricane Irene because we got a bunch of data from the American Red Cross as to their donations and where those donations were coming from for that hurricane, right? And again, we use this data. We were able to also look at 10,000 mobile donations, 28,000 web donations. Oh, no, a little typo that creeped in when I changed formats. So we were able to look at these to try and look to see if there's a relationship between the donations and the Twitter activity. So again, just showing a rough description of what's going on here, right? So the green dots in this map are indicating the donation location, and the red dots are indicating Twitter activity. And at a first glance, right, you're not seeing a lot of green dots where you're not seeing red dots, and you're not seeing a lot of red dots where you're not seeing green dots. So, this doesn't prove anything. This is just kind of high level. Let's kind of just check it out and see if there's anything to our hypothesis. So we thought that this was useful to continue to explore, right, as to what was going on. And so one thing we did to kind of make the analysis easier from the descriptive level was we first split the all states into one of three categories: highly impacted, somewhat impacted, or not impacted, right? And we looked at the fact that what percentage of mobile donations, which were donations from text. So I don't know if you remember, but a lot of times, the Red Cross will say, if you want to donate, text help to 55555 or whatever, right? And you'll donate $5, right? So we looked at the mobile donations. We looked at web donations, which is where someone went online and typed in a donation. We looked at the number of tweets, and we looked at what the overall population was, right? And so roughly, if any of these numbers are higher than that percentage of population, right, then you're seeing more impact from that particular aspect than you would expect to see, right? So mobile donations is about the same, right, for all the areas as the population, indicating that there isn't much change there. Web donations is maybe a little different. It seems like areas that are the highest impact were more likely to donate. Interestingly enough, the somewhat impacted area was less likely, right, than their population to donate, right? And then the tweets, this is the most interesting. You definitely see the heaviest concentration of tweets coming from the areas that are the most highly impacted, which maybe is understandable. So we ran this through an ANOVA examination, right? And what we found is that states directly impacted tended in general to produce more tweets and more donation, which kind of backs up this result that we were looking at in terms of exploring what's going on, right? So then we thought, well, let's look at the temporal modeling a little bit. Like, we wanted to be able to better understand how, if we have this analysis that we've done and we're kind of fairly confident that there's a relationship between tweets and donations to some extent, right? Can we use that to our benefit to kind of predict when there's going to be a particular peak of activity of one or the other, right? And so in this graph, I'm showing you tweet frequency, and this is for the whole country, right? I'm showing you online donation frequency, and I'm showing you mobile donation frequency as well. So the green is the web donations, red is the mobile donations. One thing we found out quickly, I always encourage my students to immediately do data exploration. One of the first things we found out is there's these two big peaks, right? And we're like, well, what's going on there? Why are there two huge peaks there, right? And it turns out that the Red Cross has this ability to send out these text messages to people who had previously donated, right? And that when they send those text messages out, that was when they got the most donations, right? So we're talking to my contact at the Red Cross, and we're like, so how do you decide when to send those text messages out? And they basically said, we have people who are watching the news, and whenever they feel like it's at the peak of the interest, right, then they send out these text messages, right? And so it didn't seem very scientific, getting back to kind of that liquor and guessing notion that we talked about earlier. So we changed our project, rather than, instead of focusing on the relationship between all these different categories, could we build a tool? We sharpened the research question. Could we build a tool for the American Red Cross that would predict when they should send out that tweet such that they can maximize their donations, right? And we wound up doing that. I have no idea if they're still using it, but one thing that they found early on, even from looking at the descriptive statistics, right, is that if Twitter is actually kind of a measure of national interest, right, then they should be sending out their messages much earlier. Since, if you'll notice, at the very beginning, back here in the August 27, 2011 timeframe, there's a lot more interest on Twitter about the hurricane than there is at the time at which they actually sent out the message. So our hypothesis is, and it's hard to test concretely without doing a bunch of runs of this, is that if they had tweeted at those times, they would have gotten a lot more donations, right? So, one of the things we had to do to kind of make this all work is that there's a bunch of components to this time series that we need to decompose to really kind of understand how to make this prediction. And so one thing we did was we used what's called an STL decomposition. From that, we were able to take the raw Twitter data. We were able to then decompose it into seasonality components. So this is the fact that like when people first get to work in the morning, they're more likely to tweet. Around a little bit afternoon, they're more likely to tweet. And then, as they head home, they're less likely to tweet throughout the day. And so this kind of captures that notion. Then there is a trend or the overall interest notion, right? And then there's the remainder, right? And so what we're trying to do is we're trying to predict, given all these components, at what point of the day are people most likely to be interested in this topic, right? And we did some Granger causalities just looking at the relationship between tweets and mobile donations and tweets, tweets and online donations and tweets. And there definitely seems to be some decent spaces where there is a relationship between these various variables. In fact, at this, and this is, I believe this is in hours, right? At about from about 0 to 24, yeah, it is in hours. And between 0 and 24, that's when you see the closest relationship between these two values. So our goal was to identify a 24-hour period in which you would see the most activity about a particular topic, and then tell the Red Cross to tweet, just, send out this message right around that area so that they could then maximize the amount of donations, right? So we built these two models. I don't know why this is kind of blocking some of the slides, but we built these two models, and we built a standard ARIMA model. We built a seasonal ARIMA model. The seasonal ARIMA model did better than the standard ARIMA model. And then actually the Aramax model that we built that basically took into account, so this model, the ARIMA model, is just trying to make like a moving average prediction. It doesn't work very well. This one is taking into account that seasonality component that we talked about before, about what part of the day people are more likely to tweet, right? And it does much better. And then we built another model where we first predicted out the tweets into the future, and then we predicted donations based on those tweets. And that model actually did the best of predicting the overall amount of donations you would see in the next time period. So we then built that model to start to build a tool that could identify the optimal marketing time for a particular message, right? The optimal time to send out that message. And so this up here is showing the overall Twitter data that we're taking as an input on the top. And on the bottom, you're seeing our prediction about what would happen if you were to send out a marketing event at any particular time, right? And part of this is tricky, right? Because you can't send that message out every hour, or at least the American Red Cross knows that they lose about 10 to anywhere between 10 and 20% of people will unsubscribe for every message you send out. So they want to limit the total number of messages they send out, right? Because they want to keep this list as active as possible, right? And so what they did was we decided that, based upon their rule of thumb, and this is a whole nother paper we started right up, that at most we'd want to send out 2 messages per event. And so we identified these 2 time periods early on, much before the previous time that they targeted. So these are August 27th at 9 a.m. and then again at 11 p.m. that night, right? If you look back, right, their messages went out on August 30th at 3 p.m. and August 29th at 5:40 p.m., right? Now, you could argue our model needs a little tweaking. Maybe people don't like to be bothered at 11 p.m. at night. Maybe this means that you actually send it first thing in the morning instead, right? But that's something we could work with. Now, the other nice thing we realized is they had, initially we talked to them a lot about this, they had the ability to break this down based upon, the exact regional areas of the country, right? But they hadn't done that. They'd only sent out national messages before. But in reality, they could say, hey, I want these 5 states to send this message out on Tuesday or whatever, and we want these 5 states to send it out on Wednesday, right? And that actually shifted the results a little bit. Actually, it wound up for the highly impacted area, it still made sense to send at the exact same times as you basically were for the national message, right? But for things like the area B, which was around the outside, there was actually 2 time periods that made a lot of sense to send the message. One was, again, similar to before, early on in the conversation, but the other one was very late. And essentially what we're thinking is that that is maximizing the interest in recovery efforts that are going on in that area. So people are talking about going into the more impacted area to help out, right? And then if you look at the cases where it's not affected at all, it kind of goes back to the model at the national level, right? So because that's just kind of modeling the overall natural interest. But regardless, all of our predictions wind up different than what the Red Cross proposed. Right? Another cool thing you can do, right, that involves a lot of spatial understanding of what's going on here, is we looked at, well, let's say you can choose how you're going to send out that marketing message, right? That you're going to send it out in a slightly different tone depending upon where people are located, right? And so we looked at what people were talking about on Twitter in these different areas, right? And what we found was that the most common terms near New York City for Hurricane Irene were different than the most common terms mentioned far away. So for instance, near New York City, there was a lot of concerns about the power, about it being a hurricane-opolix, right? These kind of things. And so those kind of thoughts were more on people's mind. Whereas farther away, right, there was questions about things like rains and storms and Baltimore. Baltimore was never even mentioned really in the national news at this time, but Baltimore got completely flooded out by Hurricane Irene, right? And so you might kind of take a different attempt at marketing to these different areas, depending upon what people are talking about on Twitter, right? And then with Sandy, you can find similar patterns, right? Around New York City, people were talking about concerns about food and water, right? And farther away, people are talking about, you know, the wind and how it's the rain and weather impacts, right? Rather than just their concerns about food and water. So you could do what you could do with this, and we never got to this point, but what you do with this is you could start to do real-time marketing, right? You could start to market to different locations based upon people's IP addresses they're connecting to the web, different messages. So you can imagine this is the experiment we were about to start running when basically the person we were working with, the Red Cross, left. But you know, you could imagine that this is their standard message. But then if I know that you're coming from New York and you know you're worried about Hurricane Irene, you could see a message that's asking for you to support evacuation efforts, right? And then if you're from outside New York, right, you might see a message that has to do with Baltimore and flooding, right? And then if you're in Hurricane Sandy and you're near New York, maybe you'd see one of the empty store shelves, right? And you see some message about providing food and water to people in that area. And then you're farther away, maybe you see, you know, statements about wind damage, right? And things like that, and discussions along those lines, right? So what we kind of showed, I think, in these results is that the spatial patterns of donations and social media activity are affected by these disasters, obviously. An increase in tweets, it's correlated with increase in donations. So we can use that to kind of take advantage of understanding the overall patterns of behavior. So that's the second story. And then I'm going to mention, you know, with about 5 minutes, I'm going to mention one last little anecdote about some work I'm working on more recently. It's not as exciting as hurricanes, but it's still interesting. You know, at that point, I'll open up to any questions for a little bit. I did see Laura, for those of you, obviously many of you probably noticed this already, but that looks like a great citation about who tweets at their location. I haven't seen that one. That was about the time I stopped working on that particular project, so maybe that's why I didn't see that one yet. But it would definitely be interesting to look at that data again. So I'll grab that paper after this call's over for sure. So check-ins and spatial planning, right? So this was a group at ETH Zurich who approached me about trying to use social media check-ins to help understand how retail managers can make decisions about where to place new stores and new locations, right? So I don't know how many of you have ever done this, but there's a tool, there's one called Foursquare, or now called Swarm, right, that allows you to check in as you're moving about. Yelp gives us the ability, some Facebook has this ability, right? There's a lot of these kind of physical check-in locations. And again, you know, much similar to some of the questions earlier, right? There's not a lot of people who use these tools, but there's enough that we can aggregate over time to get some understanding of where people are moving about, right? So customers check in over a certain time during the horizon. We're going to use that data now to try and build a model of how people decide to visit a particular business, right? And we're going to decompose that model into 3 components. The first is people who directly come to the business, right? Like I want to go to, you know, the hardware store over in Seaboard Village to pick up what I need today, and I'm going directly there, and I'm not going to you know, stop anywhere else along the way. Then there is the portion of people who maybe were attracted to the original business but went to a different business, right? You see a lot of this in restaurants, for instance, right? Where people will be heading toward a particular restaurant, they find out it's too crowded, it's too busy, and so they go to one of the other restaurants nearby, right? And then the last component is people who like go to multiple businesses, like and this is more like in the case, like I go to the hardware store, oh, you know, the laundromat is across the street, I should stop in and get something cleaned or something like that, right? So you have these different methods by which you can model how people get to where they are, right? And so we took a real data set, and I won't get into all the details about how we built this model. It's fairly complex. It's a structural model. It involves a lot of moving components, including I think they wound up, the students who wound up doing this wound up using a neural net at one point to kind of solve some of the data problems they're having. But in empirical settings, they took some data from an empirical study of public check-ins at Yelp, right? And they used Las Vegas, Nevada as the location. And they took a week's worth of data and they modeled all the people coming into that place and how they made decisions. And they looked at all the food and shopping check-ins, and then they tried to figure out how to plan a 7-Eleven location in the space, right? And what's nice about this tool, right, the way that they've developed it is that it not only gives you where direct visits would come from, right? How many people expect, but also how many people are affected by transitioning from one to another, local competition, right? Things like this. And then you can also look specifically about which firms are stealing away from your customers and which are they coming from, right? And where did your customers go before and where do they go after, right? So you can start to better understand the flow of patterns, which can help you better understand how you might make additional offerings in your firm, make additional events, maybe think about who to partner with, who that you need to be competing against better, right? In order to try and solve some problems that are related to where people are moving about in this space. So, you know, the interpretable model really helps us recover a lot more of how customers move through this space. And, you know, that provides one thing that I like to think about, which is managerial insights, right? By overcoming these some of these more black box approaches, which just try and predict future patterns of behavior based upon current patterns of behavior, right? So I'll end there. I did want to kind of quickly mention, I'm very interested in continuing to pursue this work, and you know, if there's a project that people are interested in looking at, please feel free to adjust me. You know, I'm brand new to the center here, Ross, and so that I'm very excited to be a part of it. I'm excited to take some of the tools that I've built in the past, like agent-based modeling and social media data mining, and some of these tools, and help them apply to some of the projects you're working on. I do have this big vision that I love to share with everyone whenever I give a chance to give a research talk about how cool it would be to use social media data, because it's real time, it's always flowing, to build kind of a model. There's this concept in a lot of operations management right now called digital twinning, right? Which is the idea that you build a model that almost as closely as possible represents your actual industry, right? So airports talk a lot about this, that they could build a digital twin of the entire airport so that they know where every plane is and where every refueling car is and where every bag is and all that kind of stuff. And the reason why that's useful is then you can ask questions about like, well, if I close down this gate, what's going to be the effect on traffic for the next week, right? So you can imagine a similar model, but built for, say, a city, an urban area, right? That's fed by social media data that's constantly updated and constantly refining the interests that people have, right? And what they're doing and the actions that they're taking, right? And that model, I think, could be very useful for a variety of reasons, right? It could help you with things like traffic planning, like trying to decide where to put new lanes and what alternative transportation methods to use, right? It could help you with questions around things like trying to decide how to pedestrianize streets or cities, ideas about where to build new parks, right? And so there's a lot of areas, I mean, even things like taxes, right? Trying to figure out, looking forward, what are the effects on tax revenue of closing down certain businesses and areas, right? And I think that would be a fantastic model to work on. I have written that proposal up a couple of times. It's always gotten shot down as being too data hungry and not research question driven enough, right? But if there was a good research question we could come up with, I'd love to explore that topic some more. So with that, I'll leave you that with a little bit of my vision of areas of interest I have. And I'd be happy to talk about this or any of the other work I've done and any questions. So thanks everyone for having me.
Yeah, thank you so much, Bill. Really interesting talk. I liked your final vision ideas. We should follow up on that. Like I was saying earlier, most of our faculty fellows are developing and applying geospatial analytics for environmental problems, and your perspectives from business and marketing are really, really unique for us. Great addition to have that perspective.
Yeah, well,
yeah, okay, so let's open it up for questions. Maybe we can try to start out by doing them by voice and see how far that goes. Of course, you can also give Bill a question by the chat line. Don't be shy.
Hey, Bill. This is Okan Pala from the Center for Geospatial Analytics. So I've been listening to your talk. Thanks for presenting today. I wanted to kind of add on to what you're talking about as far as the identification of different demographic sections and reaching out to them for specific purposes. So it could be, as you mentioned, it could be for to increase revenue or increase the donations that they might do, or else it might be for public information because different segments of demographics might need to hear different kinds of information. So based on this, I have an ongoing project that I would like to talk to you separately. So I will reach out to you through via email to send you some information, see if you're interested in collaborating. So I just wanted to mention that, and I don't have a specific information on a specific question on what you just presented. It looks cool. One thing is that I'm curious why you stuck to Twitter data only. So
yeah, great question. So the simple answer to that is that it was at the time when we were doing this. Most of this work's about, most of that work was about 5 or 6 years old. My newer work, goes beyond Twitter data. But at that time, it was honestly, the answer was it was the only data that was easy to get, right? The Facebook API has always been fairly restricted, right? And most of the other platforms out there aren't as updated as frequently. And the other comment I would make is that for things like natural disasters, Twitter seems to be a much more popular platform than a lot of these other areas. Now, there's conversations that happen on Facebook, don't get me wrong, right? But because Twitter is limited and people can tweet like as the events are unfolding, right, it tends to be a more prevalent, more commonly used area for that space.
Right. Well, if you were to redo this, would you prefer to use Google API to reach out to locations where, figure out the locations where the customers are going at certain times. So you use the like a Foursquare or other explicit, explicit sources of information where people have to say, hey, I'm checking into this location. Whereas Google actually pulls out this information from everybody's phones. And if you go look at it like let's say restaurant or a grocery store where my wife has been using to see before she goes out at 7 a.m. for a grocery run, she looks at to see how many people are already in the
honestly, I haven't looked into that. I mean, that data is also, one of these things where that data has become available since this project started to some extent. And I actually haven't looked into it too much to see how much that is publicly available. I know you can get the regular patterns of activity, right, that a business has, because I played around with the My Business API to get that. I'm not sure if you can get anything that's updated more than on the seasonality basis, right? If you, I don't know if you have any knowledge about that.
They have the projections, and they also have currently this many people are in this restaurant.
So you can probably grab that over time. Yeah, that would
No,
work.
they had the overtime one, but they also have the current one, so you can
actually right. No, that's what I'm saying is that you could build up a tool to pull down the current amount, right, on a regular basis, and then you can use that modeling.
If you develop a script that could use their API hook to pull out that information on a regular basis for specific locations, we can build that.
Yeah, so one of the reasons we like about the check-in data, right, is that we can collect it retroactively, right? So we can, and I'm not saying this it's not a good reason to use it. It just makes it easier, right? We can go back and we get time date stamps for when those check-ins occurred, right? Whereas my understanding of the Google data is we'd have to build up a tool to start collecting that data going forward, right? But it would be interesting to see. I don't know how much of the historical data they make available. So yeah, it's a great point though. I'd love to take a look at it. I did want to mention briefly at something else you mentioned earlier in your comment about trying to figure out who needs different messaging, right? Actually, in a lot of the work I'm doing right now, it's actually on, it's around understanding adversarial conversations in social networks. So specifically how a lot of times is China and Russia are influencing social media conversations in the US, right? And understanding the evolution of those conversations and why people respond to them and why people interact with them. And it'd be interesting to think about, you made me think about, like, is there a spatial component to that as well? And there might very well be that I hadn't considered before, right? That maybe the conversations in the South that they're able to exacerbate are different than the conversations in the North. And I hadn't really considered that. That would be fascinating to look at.
Yeah, I totally agree, because different political views, run across different types of demographics, and those demographics vary spatially. So adding the spatial component on that, along with the demographics, might give us a better picture of these conversations, and might also give us a better picture of these misinformation campaigns.
Yeah, and that could apply also as well to some of the discussions about climate change and things like that as well. I could see that outside of the political discourse that we're looking at. I actually published a paper recently on how different climate change discussions occur in response to natural disasters like Hurricane Irene, Hurricane Sandy, and some of the big snowstorms. And I bet we didn't look at the spatial aspect of that either, but I bet there is a spatial componentry there as well.
Yeah, there's all kinds of fun stuff to do. So
yeah.
Hi, Dr. Rand. Yeah. Hello.
Hi, Morgan. Yeah.
Yes. I'm Morgan. I'm a civil engineering student. Thank you for your talk today. I work with Dr. Emily Berglund.
Oh, yeah. I know Emily.
Yeah, we're actually doing a study about social media behaviors as they relate to hurricane events. We're looking at Hurricane Florence and Michael.
Oh, nice.
Awesome overlap today. I don't know if we had connected over that before. But something that we've run into with agent-based modeling is the ability to go back and validate the content of what people are reporting their behaviors are, or maybe what they're saying on social media. So any challenges you had validating what the content of these messages, or also going back and having privacy issues or challenges, have you ever tried to reach out to the people who are posting these messages and confirm what they have said?
Great questions. Yeah, great questions, both of those. The first one with validating, you know, that was part of the reason why we restricted our modeling to just looking at where they were, right? According to geotags, right? And did they tweet or not? And we didn't really look at content at all. We didn't try and look at, did what this person say, when they said a certain thing, did they actually say it in that space, right? And so from that perspective, right, we didn't really do much of the validation at that level. I did have a project I briefly worked on where we proposed doing a validation that I thought would be very interesting, where you take a particular tweet and you try and identify where someone is, and you could use not just geotagging, right, but you could also use things like their assumed, their stated location, and you could use things like any pictures or images that they've shared, right, to try and infer where they actually are, and then calculate. And so the only thing we were going to validate was they made a statement about this location. What's the probability that they actually have any knowledge about that location, right? That they were close to that location. So we started to build up some models, but we never really got very far along those. So that was something we did look at. And then your second question, I forgot what the second question was.
It was just if you had personally run into any challenges with privacy or the ability to reach out back to.
So, you know, we never published anything that was disaggregated. I occasionally will publish individual examples just for not even publish, but just use them in presentations and things like that. And a lot of times what we tried to publish in those cases, I tried to identify users who were public personalities, essentially, right? Yes. That they acknowledged that they were, you know, like one example I use in a lot of talks is one where they basically state openly that they are a social media scientist, right? And so if someone is a social media scientist, I think it's fair to infer that they have knowledge about how their data is in the public eye, right? And so could be used to be presented, right? And so I'll deliberately use, I placed, you know, well before IRBs came along and started, you know, putting up guidelines, we were already using those kind of rules to guide privacy disclosures. That being said, you know, I haven't run into too many problems with it. We did. Oh, this is the question I was going to answer. You asked if we'd ever tried to reach out to any of these individuals.
Yes. Yeah.
And so, yes, it did take us almost a year to get it through IRB, but we did get an experiment where so I had an experiment where we were looking at bot behavior and how users interact with bots. And in that experiment, we did get permission to reach out to individual users and contact them and ask them why they interacted with the bot, how they interacted. We did a whole survey with them. What we found is that not many people responded, right? Which was fine. We weren't really trying to see if people responded. What we were trying to see is if we contact them and told them they interacted with a bot, did that affect their behavior in the future, right? And unfortunately, in the study we looked at, we didn't find much of a change in behavior. Now, the power of the study could have been too low. We didn't reach out to enough people or whatever, right? We did like a randomized controlled trial where we quasi-randomized, I should say, or quasi-controlled, where we reached out to half of them and didn't reach out to half of them. And we didn't find much change there. But, you know, so I would love to revisit that experiment, but we weren't able to find much change. Now, my learnings from that were interesting. One thing that we learned was that apparently Twitter, if they identify you as a bot, will do this. There's a specific word I'm dropping on, but they do this thing where they kind of block you, but not really. So your tweets are visible, right? But they won't notify a person that you've tweeted at that they've been tweeted at by you, right? So they'll stop the notification from going out, which means that your tweets are a lot less likely to be seen. So we had some concern that maybe our tweets were never even seen, right, as a result of that. So it's something to keep in mind as you go through that process.